So welcome to this session. If you like magic, magicians, Harry Potter, whatever you name it, you're in the right room. If you like profiling, you're also in the right room because we are going to transform profiling into metrics. So how many of you is using profiling here? Quite a bit. How many has no idea what is profiling? Oh, nobody. Everyone is no. Oh, so I'm going to talk to you. All right. So let me introduce myself. My name is. Okay, that's the. Okay, too fast. Okay. Let me introduce myself. Today, I'm going to be the dark wizard of profiling. I'm going to explain you why I became that dark wizard. But stay tuned. The story will happen soon. But before, let me introduce myself. My name is Henrik. I'm a cloud-native advocate working at Dynatrace, a bit more than 4 years now. And also a CNCF ambassador. And I'm so glad to be here because I love the observability community. I love the cloud-native community. It's such an amazing community. Everyone is so nice. But prior to interacting with this amazing community, I've been working as a performance engineer most of my career. So testing, tuning, breaking, optimizing things. I think it's an amazing practice because it's the best way of learning different architecture patterns and then basically go and tweak systems is through performance engineering. So if you are new in the industry and you want to learn fast, go for it. It's amazing stuff. So that's why I'm trying to build content when I have time, which is more or less often, to be honest, on a YouTube channel called PerfBytes. So we share methodology about performance engineering in general. So that's the channel, the red logo that you can see here. And then otherwise, since 4 years, I started a YouTube channel called Is It Observable, where I try to cover observability, Kubernetes, security, whatever, but focus mainly on the observability. Of course, you have it on the name. All right, so what are we going to trick here during this next 28 minutes? Well, a couple of things. I want to explain you how I was able to transform profile into metrics. There's been a real journey behind the scenes. So to be able to explain that, I will have to remind the value of profiling. Why do we have profiling? What's the purpose of it? When do we actually use it? Because at the end, you don't need profile for everything. And then we will look at deeply on the OpenTelemetry data profiling data schema, because at the end, if you want to start manipulating your profiles and transform it into metrics, you have to understand how this data is stored and how it's been structured in an OpenTelemetry format. And of course, naturally, my first reaction say, I want to transform. The collector is there. It's my best friend, so I'm going to use whatever is available on the collector and try to successfully transform that. So we're going to cover the OTTL aspects covered from OTTL is OpenTelemetry Transform Language, for those who never heard about it. So we're going to cover the support on profiling. So they have started to support profiling, which is amazing. And then we'll see at the end how I was able to convert those profiles into metrics. All right, so let's start. Starting with the dark art of performance. The dark art of performance, so let me remind my journey as a performance engineer. So if you have a project, you have to test it out. And so you throw some load on a system, not randomly, of course. You try to make a realistic traffic. And then you collect data from your system. And remember here, I'm telling you a story about 10 years ago. So we don't have OpenTelemetry. Keep that in mind. We don't have those fancy traces. Keep that in mind. We just have the raw data. So what were we doing? We were first thing that we were doing is going through metrics. Metrics was our best friend. So you know the architecture, you know the dependencies. So you start at the front door of the architecture, and then you go down, drill down to the different layers. But you look at the metric side. Okay, say, all right, is it performing well? Do we have an issue? Where is it potentially located? And suddenly you look at the counter scores, exceptions per second or error per second, and say, okay, there is something wrong here. So that's why we go directly to the other best friend that we had, logs. So we go to the whatever server that has the logs available, we pull it out, and then we don't have fancy queries. You basically search in the log through timestamps, and then you figure out, okay, that's a problem. Now I can understand that we have an exceptions, and that's the reason, that's the code, blah, 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 and so on. And lucky us, if everything was there and we were able to successfully point out the problem, voila, we finished our work. But sometimes it's not always the case. So that's why sometimes it happens, depending on the projects and the customer that we had the luxury of having solutions that were producing distributed traces. So that at that time it was named pure path. So here we had the pure path. And then from there, we're looking at it and say, oh, amazing. Now instead of looking at the metric side, I can see through distributed trace where I'm spending time. And then I can narrow down my analysis on that component. So that's being more efficient. But when it comes to CPU consumptions, and when it comes to memory, if we have a memory leak, we see that the memory is dropping down, the traces were not very useful. So that's why we turned on profiling. And profiling was very expensive at that time. You don't turn it on with thousands of users. You know that you have a problem, you turn on profiling, and you try to get some profiling data, and then you can try to analyze from there. So that was the thing. So out of that, we clearly have a conclusion. We have 4 houses of performance. Starting with metrics. Metrics is one of our best friends that we use in everyday production troubleshooting. And we have logs. If something is bad in our code, we have errors, we have exceptions, we're going to utilize logs because logs is amazing. And then we have distributed traces exactly designed to point out where we are slowing down, what's the problem, where it's located, amazing. And last we have profiling. Profiling is, again, now to these days we have continuous profiling, which is lighter, more efficient, so we can turn it on production without having problems in our applications. So where do we have to use those signals? Where first, like I said, we start with metrics. But metrics is going to show you, okay, we are above the thresholds or we are slower than expected. So it will tell you things, but it doesn't tell you where. We don't answer that question. That's why if we have errors, we go to the logs. So we can understand things, but if there are some memory consumptions, if we have some CPU consumptions, it doesn't tell you where as well. So logs is not the great thing. And then traces, like I said, it's amazing to figure out the performance bottlenecks. But when it comes to optimization, we cannot utilize it. So that's why we're going to use profile. And you know that we have flame graphs. There's a different way of visualizing flame graphs. And here it's just an example, a very synthesized example where I have a main functions. And then I see that if I want to optimize this main functions, because I know that we have a memory leak or we have a high-speed CPU consumptions, I can use the profile and say, OK, here, parse JSON is consuming 40% of my CPU resources. So I can optimize that profile. So now we know that through the profile, which is great. And the other thing that we should have to keep in mind in today's world, Austin mentioned about using our LLM or machine learning. We're using so much the cloud now these days. We are consuming resources on the cloud. We're consuming resources through AI agents, and we're just burning energy. And if we want to be a green cloud native engineer, we should be cautious about how much resources we're consuming. And the best friend for that, if you want to optimize your systems and avoid consuming energy because we just think we want to implement LLM applications because it's great, we have to optimize. We have to tune. We have to make sure that we reduce the CPU cycles, reduce the memory allocations, then our code will consume less resources in the cloud, meaning that we will be greener and we will have a better impact for our Earth. So keep in mind that. So profiling, when it comes to sustainability, I think it's one of our best friends because it helps us to optimize systems. Now, since Valencia, KubeCon Valencia, OpenTelemetry project decided to add profiling into the project, which is fantastic. And this is where all those houses that we had, so metrics, traces, logs, and profile, are now all together working in the same castle called OpenTelemetry, where we have trace ID, we can correlate things. And I think it's just fantastic for the new performance engineer working now. It's going to be so much efficient. In London, I don't know if you had the chance to be in KubeCon London on Observability Day. I was sitting here, not here, but in London, and I was listening to that talk delivered by Damien from Elastic and Felix from Datadog, where they were sharing the state of OpenTelemetry Profile. So they show things about the ebpf profiler that is available on the collector. They explain the flame graphs, how you could process things. And then when I was during that session, I say, oh, I want to try it. I want to play it, but I don't need the full-fledged profile. I don't need it. I just, what I'm looking for, I want to basically be able to get from a process perspective, get what is actually consuming. Because at the end, with the profiling data, you have that information. Or I want to basically, if I have a memory leak, I want to basically target one of my process or one of my functions and just measure over time the memory allocations. So I naturally said after that session, oh, what I want is to take the profile and convert it to metrics. OK, challenge accepted. Let's do it. So I submitted that session at KubeCon, and then you'll see that I went through that journey. It was not that simple that I thought, to be honest. So when I started, I said, OK, so if I want to do this, how can I convert that profile? So first, let's do the experiments. Let's generate profiles, look at the data schema. So let's understand the data schema of OpenTelemetry. And then, text to collector. OTTL is there. There's a support. So we should be able to, at the end, convert that profiles and produce the CPU utilizations, the memory allocation of our processes. Awesome. Let's go. All right, let's start. So let's generate some profile. So to generate some profile, the natural choice, because I'm usually utilizing Kubernetes clusters, so I'm going to use the collector. And I don't know if you followed the OpenTelemetry project, but there are several collectors in place. We have the natural OpenTelemetry collector that you know, that process metrics, traces, logs, which is that you've all been used to use. And there's another collector in the collector release called the ebpf-profiler collector. So this is basically a collector that has all the features that we need just for profiling, meaning that it has the ebpf profiler receiver. So at the end, it's the profiler agents that will collect profile from the cluster and produce profile in OpenTelemetry format. And then it has only the right processors for profiles, meaning a bunch of processors, so the resource detections, Kubernetes attribute processors, batch, and so on. And then you can export, and it does, as of now, from an exporter perspective, it does only OTLP and OTLP HTTP. All right, so how can we use it? If I deploy it on a cluster, what does that mean? I need first a daemon set deployment, so with the ebpf profiler collector, and that ebpf profiler collector will basically have this collector that I mentioned. Why do we have a daemon set? Because obviously we want to produce profile from each node of our cluster. Simple. Once we have this, we will need other collectors. So here we have another collector. You could deploy that as a stateful set or deployment, depending on how you prefer your deployment model. And the other collector will be in charge of metrics, traces, logs, whatever you're currently managing your telemetry data. But the profiler collector will be there to send also its profiles. So then we can do something in that getaway collectors with the profiling data. All right, let's go. So what does that mean? So first we will have this generate some profiles. So what I did is I took the ebpf profiler as a daemon set. I used the collector pipeline with profile, meaning I will have to use the receiver, like I said. So here I'm generating 19 samples per second. And then I'm trying to enrich that data with the information related to the resource, so the container, the namespace, the deployment name, and so on. And then after that, I want to produce debug, because at the end, when I want to look at the data, and you can see on the right side of the screen, you can see that we have the profiling data available in the console export. You can see that with a couple of information, so profile, we have samples, with a couple of things. Okay, interesting. So maybe we can start drawing a map and look at this profile schema. And from that profile schema, we'll be able to figure out how we can basically parse it. So the profile schema, if you look at the OpenTelemetry specs, you can see them. So you have the profiling data, which is the main resource that will hold everything. Inside of that, you will have the resource profile with the resource attributes. So like any signals of OpenTelemetry, you will have the resource attributes. So that will be held at that level. And then you have the scope profile with the instrumentation scope again. You also have it on many signals of the OpenTelemetry project. And then inside of that, you will have the profile with the samples. So you have a sample that gives you some details. You have a location table. You have a function table. And then you have some mapping and some string tables. Like, okay, interesting, but what does this actually mean? If you go back to our flame graph that we had, so the very simple flame graph that we had, you can see here that I have a stack of calls. So main, process request, parse JSON, with the name of the function name, the name of the file, and the line where this has been used. So this is basically the pile. This order is stored in an array called locations. So I have an array with different, every function calls. So that gives me the order. And then this makes a reference to the function table. So the function table is basically, location is pointing to an index in that function table. And in the function table, it says, okay, so I'm based in that file, and I'm based, and this is the name of my process. And here is the line. So it's, again, no strings, only reference to a string, to index numbers. So if I want to get the actual value, the parse JSON, the parse go, all the strings, I will have to make a reference to with the index number to the actual string table. Okay, so now I understand the challenge. If I want to parse that data, it means that I'm playing mainly with index number and not strings as it is. Okay, so now, what do we have in the collector? A couple of things. So we have currently a couple of processors. So I went to the OTTL contrib repo and I looked at the code who has the scope, the profile signals included into their process. So we have filter, very useful. Kubernetes attribute processor. We briefly saw it in the previous pipeline. Memory limiter, resource detections, resource, and transform processors. And in terms of connectors, we have two of them, count and signal the metrics. But then, out of those processors, there are a few of them, which is filter, transform processors, and signal to metrics that are using behind the hoods OTTL. All right, so who knows OTTL? There's a few hands here. A lot of maintainers that was raising the hands better. So OTTL, for those who never heard, it's a language that is used to transform and to manipulate OpenTelemetry data. So to be able to manipulate the data, you need to define to OTTL what are the contexts that you're going to target your actions. So context is mainly helping the collector to say, okay, I'm going to look at that area of the data instead of the broad range of the data. And for each signals, you have different contexts. For metrics, you have the metric with the metric definitions, and then all the data points that are stored in data points. So if you want to manipulate attributes that are on your points, you will have to specify data points. And on the logs, on the traces, same thing. You have the span, and then you have the span events. So if you're targeting the span events and manipulate the span events, you will precise the context span events. Logs, I think it's the simplest model, just logs. And then you have a common, which is for all the resources. You will always have resources to only target the resource. Or if you want to target the instrumentation scope, you can also do it through the context instrumentation scope. So what about profile? Well, profile has its own context that has been introduced, which is very exciting. It has resources, like the common object that we saw before. We have the instrumentation scope, like we saw before as well. And then it has a profile. And the profile, you can see we have attributes, we have time, and we have duration. We have other properties, but the downside of this is as of now, those properties are specific data type, which is value type, which is sample slice, and there's no methods to get that data. So you cannot access to the data. You can see the data, but you cannot actually access to the data. And this is going to be improved soon. It's just a matter of time. So if you want to play with the samples, make sure that if you want to differentiate, this is a sample for metrics, this is a sample for CPU or a sample for memory. As of now, you cannot distinguish them. That's the only downsides. So out of enrichment, what can we actually do? We can, of course, enrich with Kubernetes attribute processor, with the host resource detectors, if you're in bare metal or virtual machines. You can add static resources, and then you can filter. The other action is filter, so we can basically drop only based on attributes. All those samples coming from that attribute, I will drop it. Or I can modify. Let's say I want to add into my attributes this type of details. So as you can understand, as of now, the only thing that we can touch base is attributes. And that's the only thing we can do. So let's transform metrics. All right, so first thing that I did, I say, OK, I'm going to use the available connectors. We have 2 connectors available, count. So that would basically help me to count the profiles coming through the collector. But here I don't care. I'm not looking for that. The other one is signal to metrics. Signal to metrics, for those who never heard, is the connector that can transform a signal, trace metrics logs, into a metric. And you can do a bunch of actions. So count, sum, do some things. But the problem, if you look at it, I cannot distinguish CPU and memory. I can count the number of profiles based on attributes. So I will have a counter of how many profiles I'm generating for the service, I don't know, a cart. But I cannot say this is a CPU profile or this is a memory profile. So that's a downside. So how can I do that? Well, I said, OK, I need to produce something for this session. So I said, OK, let me build something. So I decided to build my own connector called profile to metrics. So this profile to metrics is experimental, again, because I don't think I'm the best coder of the room here. I just wanted to see if it's possible. This is basically producing CPU time, memory time, and I'm parsing the actual sample data schema, looking at the string tables and everything. So here you can basically say, I want to just focus on node metrics, the process node, if you're a Node.js developer, and then you will go through the sample and gets the CPU time and the memory allocations. And you also, if you want to get the file names, because maybe you want to see which file name we're talking about, we have the options to enable the functions in the data metric produce. If you do that, keep in mind that you will basically add some extra dimensions that will be quite expensive due to high cardinality. All right, let's make a few small demo. If I have time. This is the environment. So again, same collector we discussed. I'm adding Istio in the picture, the OpenTelemetry demo in this example. Here's the QR code to the environment if you want to play around with this. And if I go back, I'm going to show you. Oh, I need to change the display. All right. So this is first. This is the repo, my local personal repo with the documentations. You can look at it. You have to enable it, so you can profile to metrics. It's on my repo. What I have done here, just to show how it configures, here is the connector. So here I'm enabling the functions because I'm interested to get the function name back to as a metric. And precising which type of metrics I'm interested in, the CPU or the memory. And on the bottom here, I am only filtering. I'm interested only to get all the samples of the process related to Node, because I'm the Node.js process. So which means I will only get those metrics out of that. So if I go now, in my case, I'm using Dynatrace. If I go to Dynatrace, I can show you if it's loading. Ah, OK. So that's a dashboard that I just built with those metrics. But let's build a new tile with metrics. And I'm going to search for the value which is, let me just grab the actual metric name to avoid searching for nothing. All right, so here I have the metrics. And then you can see I will get here the file name if I want and the function name. And then I can just basically collect this data. Here it is. So here I can see that, I have some null data, so could be improved. But here I can send some information on which file it is and which process it is. So at the end, my objectives of building metrics out of the profile is achieved. And I did the job, so I'm very happy about that, to be honest. But again, this is an experimental plugin. If you're interested in it, let me know, because I didn't push it to the OpenTelemetry contrib repo, because maybe it's very specific to my needs. If you think it's useful, let me know. So maybe we could improve it and make it better for all our community. If you want to have some small promotion for my YouTube channel, is it deliverable? There's plenty of content about OpenTelemetry, profiling will be soon. But yeah, check it out. It's out there. Consume the data, the content. If you hate it, if you like it, like it. If you hate it, but let me know, so then I can improve my content. All right. I don't know if you have time for questions. We have 0 time for questions. But there's 2 QR codes, so if you want to send me some feedback on the presentation, scan the QR code on the feedback. And if you want to just chat on the content later on, just scan the other QR code. All right. Thank you for listening to this session.